Good
Yes, ma'am.
evening, one and all. Am I audible?
Yes, yes, yes.
Yes,
Okay.
ma'am.
So it's with great pleasure that I welcome all of you to this 55th QCrete webinar, organized in uh, connection with the webinar series that is being conducted by the Indian Concrete Institute Kochi Center and in association with QCrete Readymix India Private Limited. Today we have a very interesting talk on new age additives for concrete and cement by eminent speakers, Dr. Ramkumar Natarajan and V.R. Kaushika. And I now invite Mr. Engineer Sanulal to uh, introduce the speaker to the audience.
Okay, am I audible?
Yes, sir.
Hello. Yeah, good evening, everyone. First, please allow me to express my humble gratitude to introduce our eminent speakers for this webinar. Dr. Ramkumar Natarajan, Director, Nevada Science Private Limited, and Engineer V.R. Kaushika, Executive Director, QCrete Private Limited. Dr. Ram Kumar, he is the PhD holder in material engineering, and he has very rich experience in cement and concrete. I would like to share some of his patents. Permafrost ceramicrete and lightweight phosphate cement for deep water and cold bed methane wells. Low embodied energy wallboards and method of making the same aluminum phosphate ceramic and coatings, cement composition with fly ash, magnesium phosphate based cement, mortar and concrete composition with increased working time. He has done very good job in the field of the cement and concrete. Now let me introduce our other speaker, Engineer Kaushik. He has over 29 years of experience cement and concrete. Now he is working as a director QCrete Readymix India Private Limited and executive director of QCrete Private Limited. And he has very rich experience in ready-mix concrete, admixtures, etc. And I am also would like to share some of his achievements. He published articles on concrete-related topics in many national publications. Regularly giving lectures in National Council for Building Materials, Engineers Staff Colleges of India, and many other engineering colleges. He has been almost given about 150 lectures in various institutions, conferences in last 10 years. So as an engineer or construction professional who all are closely associating with the cement and concrete should have to know about the additives and its importance. So nowadays we all are looking for the right product for right application. So definitely this section will enlighten us. And thank you very much all.
Good evening.
Now, okay, sorry. Yeah, please go ahead. Go ahead.
Thanks for the introduction, Mr. Lal, and thanks, Sunita Madam, for the introduction for the speakers. I, on behalf of QCrete and QCrete, I take this opportunity to introduce this product, iCrete. In fact, iCrete is, I can say, the brainchild of Dr. Ramkumar. We are happy that he's with us actually. In fact, he knows in and out of the product because it is his formulation and it is his patent. He has asked me to talk about iCrete. So I think it is a privilege that I am trying to talk about this product actually. Next slide. So we call this product as next generation additive, concrete additive. I will just speak why we call this as next generation additive, just because that there are not much parallel additives or similar additives which perform in the concrete like this. It is a completely different technology, a different approach to make concrete better, and that is the reason we call this as a completely a different technology, and that is why we call this as a next generation or a novel additive. I will just, before we go to the next slide, I just want to introduce why we started using this product, or what is the importance of this product before we move on to actual presentation. Actually, in 2020, when this corona started troubling all over the world, most of the Readymix companies in India had the trouble of running the companies, and many of the companies were having a lot of problem in cash flow management and things like that. And every company was looking at how to optimize the mixes, how to optimize their operations costs everywhere. So in this connection, we started this, and I happen to know Dr. Ramkumar, who is the inventor of this product, from 2012, and it was for me a godsend opportunity to explore the possibility of using this product. And most importantly, before we go to next slide, it is important to know the basic objective of this product is other than the other benefits it brings on to the concrete, is the mix optimization. Next slide. QCrete is a novel additive which is added during concrete mixing. It is available in the powder form. It is a carefully selected blend of microminerals, and it conforms to ASTM C1797. The product reacts with intermediate phases of cement to increase the strength and durability, and it is completely different product. It is not a super plasticizer, and it helps to increase the profitability and durability, and also it helps to increase the use of supplementary cementitious materials. We'll come to that one later. Next slide. So as we just talked about why we should use QCrete. QCrete brings great leverage for the producer, concrete producer. He can optimize the mix by lowering the cement content either, or he can increase the SCM loading actually. So for example, if we have OPC mixes, let us say for example we have a mix of OPC 400 kgs or 450 kgs at a particular dosage like 1.5 or 1.8 or 2%, we can reduce about 50 to 55 kgs per cubic meter. And on the lower end of the dosage, if we have 0.8 or 0.7% dosage, we can reduce about 20 kgs per cubic meter. So the range is between 20 to 50 kgs. OPC, directly from OPC to OPC we can reduce. On the other hand, we can also reduce the cementitious content itself. For example, we have a OPC plus GGBS mix. Let us say 450 kgs total. We can reduce the total cementitious content from 450 to 400 kgs or 390 kgs. Sometimes we have got the result 75 kgs OPC plus GGBS total cementitious content has been reduced. We have got results. Similarly, OPC PFA mix, if you have a OPC PFA mix total, let us say 400 kgs, you can reduce the total cementitious content either, or we can increase the SCM loading. For example, somebody is using a 40%, 50% GGBS. We can go down to 40% OPC and 60% GGBS, or 35% OPC and 65% GGBS, and use iCrete. So in fact, SCM, more the SCM, better is the performance with the iCrete. So it helps to reduce the cementitious content. For example, you have a mass foundation or a thick foundation with a high grade concrete. So you cannot use more OPC because heat buildup takes place and then you have thermal cracks, etc. In such situations, you can reduce the OPC content and increase the SCM content using the iCrete, and hence it solves the problem of the designer. Next. So why we should use iCrete? The important point is like durability to owner. So it is not, even though the main purpose of this product is to optimize the mixes, which is very interesting and useful to any producer, concrete producer. At the same time, the beauty of the product, and why we call again and again this is a novel additive, is it not only reduces the cement content or cementitious content or SCM loading is enhanced, but at the same time the durability is enhanced. And of course, when the cementitious content or when the OPC content goes down, the sustainability becomes better, the product becomes greener, and hence the environmental impact reduces. In that way, even the total carbon dioxide emissions, or rather we can say the embedded carbon dioxide and then the other associated environmental factors are enhanced. Next. So when we talk about this product, the most interesting and important question everybody asks is how iCrete works actually. And as I said, is like I'm like a student explaining in front of the teacher. I'm explaining this in front of Dr. Ramkumar. Here, the point is this: it promotes dissolution of alumina and iron present in the supplementary cementitious metals and cement. So we know that the alumina and iron components are available and present in cement and cementitious systems, and iCrete works on these materials, and then it accelerates the hydration of intermediate phases and increases the rate of silicate reaction, and most importantly, it forms additional binding phases other than calcium silicate hydride gel, which is normally formed in any cement hydration process. So it forms additional calcium silicate hydride, other products other than calcium silicate hydride gel, and that is how it works on a different level, and that is why we call this as a totally different technology. Next slide. Next slide. So iCrete, when additional binding phases are formed, it fills up the capillary pores and then the pore size is reduced. So that is the important work of the iCrete. In combination with this alumina and the iron present, it forms new binding phases other than calcium silicate hydride gel and fills up the capillary pores, and hence makes the concrete denser, impermeable, and stronger. Next. Next. So, madam, previous one. So what is the difference between iCrete and superplast scissor? Any superplast scissor, we know when it is based on SNF or PC based admixture, it does not react chemically with cement. It acts as a surfactant, or it increases the distance between the cement particles. It increases the flow or reduces the water content. Whereas iCrete chemically reacts with the concrete, lowers the permeability of concrete, it reduces the cement content, ICrete, and then increases the SCM use, and it increases the SCM usage, and then most importantly, there is no effect on the workability. There is no effect on the workability or rheology. So whenever a pumpable mix is produced or a concrete mix is produced using a superplasticizer, whatever the workability and the retention part is there, 1 hour, 2 hours, 3 hours, something like that, all that is intact, and ICrete doesn't interferes with the normal retention which happens with a superplasticizer or a superplasticizer cum retarder, and also it does not modify any rheological property. That is the I can say one of the added advantages of using ICrete. It does not affect the workability in any way, keeps the workability intact, and in the same way you can say we get better strength and better properties. Next slide. Next slide. So some of the earlier trials, these are third-party trials, which are simple examples to indicate the efficacy of ICrete. The control mix here taken is a OPC system of 320 kgs per cubic meter, and from there with ICrete we used about 0.7% by weight of cement content, that is 2.1 kgs, and then here you can see the strength 28 day strength is something similar to the control. So by using about 0.7% or 0.8%, you can get about 20 to 25 kgs per cubic meter reduction. This is one of the very initial trials done in a third-party laboratory. Next. So the am I audible? Hello?
Yes.
Am I audible?
Yes, sir. Yes, sir.
So when we are talking about advantages of using this product, the most important advantage is, even though we are using 320 kgs and we have reduced to 300 kgs, there is a tremendous reduction in the permeability when found as per 1048 DIN 1048. So almost 50%, less than 50%, means tremendous reduction in the permeability has taken place. So as we know, reduced water permeability means increased durability. So this is the added advantage of using this product, where we have a tremendous reduction in the permeability, even though we have used a lesser amount of cement or cementitious content. And I want to bring another important point here is, when we are using 320 kgs to 300 kgs, there is always a slight increase in the water cement ratio in the ICrete reduced, means cement ICrete incorporated mixes or cement reduced mixes. So even in a mix with a higher water cement ratio, lesser cement content or cementitious content, this product gives equal or better strength and better permeability. This is the beauty of this product. So it always in a way defies the normal acceptable water cement ratio law, which says that as the water cement ratio goes up, strength reduces, or as the water cement ratio reduces, strength goes up. So here, even when the water cement ratio is slightly up when compared to control, using ICrete, you have equal or better strengths, and then better durability and better permeability and other properties. Next one. So here is again another mix done very in 2019-20 in a third-party laboratory. where 50% GGBS is used, and in higher cementitious content, when we are aiming for better strength and better permeability and other things, we use up to 2% of iCrete actually. So in this case, you can see a jump of strength between from 61.5 to 67.6. So here almost about 6 MPa strength increase has happened actually, which is significant. But here the most important point which we need to understand is when we are using iCrete in such situations where you have to increase the strength, it can take care of some small problems associated with cement or other cementitious materials, and hence it can also ensure as a insurance in high grade concretes actually. So at the same level of cementitious content, it enhances the strength. But of course, in this case, you will not be getting any economy. Here the objective is to enhance the strength and other properties. Next madam. Yes, so here again it is a classical example where the permeability is reduced in a very big way by usage of iCrete. At the same mix, we can say when 2% of iCrete is used, the percolation of water as measured as per DIN 1048 has reduced from 13 mm to 4 mm, which is tremendous reduction in the permeability, leading to increased durability. Next one. So as per IS 2645, when the product is tested without iCrete, if the when the percolation is 100% as measured as per IS 2645, it is only 18% against the control when 2% of by weight of cementitious content is used. So again, it shows the permeability is reduced in a very significant way. Next one. So we talked about OPC GGBS mixes. Now coming to this also works in a good way with fly ash mixes. Here we can see that when 220 plus 100, 220 kg OPC, 100 kg fly ash is used, against that one we have used 0.7% of iCrete and about 300 kg is used, and then the strengths are almost similar, 37.05 and 36.7. Next madam. So when we are talking about iCrete permeability test as per IS 2645, average percolation of water when 2% is used, 18% it comes down, and without iCrete it becomes 100%. So there is a tremendous reduction in the permeability. Next. When SCM pictures are taken, then you have you can see growth of crystals, and which again demonstrate that the iCrete works and helps in decreasing the porosity. Next. So SCM picture showing additional crystal growth and iCrete as a reason for decreased permeability and improved strength. Next. So XRD examination of concrete with and without iCrete shows intensity of calcium hydroxide peaks are reduced in 28 days. So you can see the calcium hydroxide peaks are reduced from here to here, and then calcium sulfoaluminate peaks are more pronounced. You can see calcium silicate hydrate peaks are more pronounced actually. So this shows that the iCrete works and changes the microstructure of concrete, imparting better permeability and strength. Next. So before we, sorry, previous slide, man. Previous slide. So as a summary, I can say iCrete is a novel additive which can be used to optimize the mixes. We can reduce OPC to OPC 20 to 50 kgs per cubic meter, or sometimes even higher. We can reduce from OPC GGBS mix to OPC GGBS mix. We can reduce the cementitious content itself, either if it is OPC GGBS or OPC PFA, or we can keep the same cementitious content and increase the SCM content. We can increase the GGBS content, or we can increase the fly ash content. Third one is, we have seen and we have heard and we have seen there is a tremendous reduction in shrinkage cracks, practically seen by many of our customers where we have used iCrete. So the plastic shrinkage cracks, plastic settlement cracks are reduced to a great extent actually. In many cases, people are using this for this single particular usage of reduction of shrinkage cracks, and then the product not only does the work of reduction of cement, but automatically it increases the impermeability and makes the concrete more waterproof. And iCrete as an additive, when it is used for optimizing the mixes, reduces the cement or cementitious content and makes the concrete more sustainable and greener. Next slide. Thank you. From here, Dr. Ramkumar sir, who is
Yes,
the
sir.
director of Navodaya Sciences, will take over. Thank you, sir.
Thank you. Sir, am I audible?
Yes, sir.
Okay. So thanks for a very lofty introduction by Mr. Lal, and once again a very insightful presentation by Mr. Kaushika. And good evening to everybody, one and all, including Dr. Sunita Madam and all the attendees. Now, I'll be presenting the product called Novomax, which is a cement additive. And so Kaushika talked about iCrete, which is a concrete additive. And before I start with Novomax, I would say that both Novomax and iCrete are on the same technology platform. So Novomax is a spin-off of the iCrete, and it helps to decarbonize the cement industry. Both Novomax and iCrete has got a one common function, which is to decarbonize the cement industry. And we will see in the coming slides how Novomax helps the cement industry to decarbonize, and what is innovative about the Novomax when compared to the conventionally available additives that are present. Madam, next slide.
Hello. Please move to the next slide.
Next slide, please. So Novomax is a patent pending cement additive. This is added to the clinker during grinding, and this is not a conventional grinding aid, and it's a blend of minerals and surface modified chemicals. When we say surface modified chemicals, some of the chemicals from the waste industries are modified in terms of its surface by imparting certain charges onto the surface, by coating certain chemicals onto it, and it chemically reacts with the intermediate phases of the cement. And this is pretty much common in iCrete and Novomax. And when we say intermediate phases, and most of the people are aware, actually cement has got tricalcium silicate, dicalcium silicate, tricalcium aluminate, and tetracalcium aluminopyrite. And this C3A and C4AF is called as a intermediate phases, and which amounts to somewhere around 20 to 24% of the whole 100% mix. So normally these C3A and C4AF, to some extent, even though it reacts, most of it are left with unreacted. what we do is actually we preferentially reacts with the chemicals that are present in Novomax and iCrete, preferentially reacts with these intermediate phases, thereby enhancing the strength and durability. So this, what it does is actually it helps to maximize the profitability and increase the use of supplementary cementitious material. By increasing the supplementary cementitious material, not only you are improving the properties of the final cement, but also you're reducing the carbon footprint associated with the clinker. Next slide, please. So once again, as I told you, it's a powder-based additive. It reacts with the intermediate phases of the cement to increase the early strength and later strength. And I'll explain you why. I mean, what happens when you increase the SEM in your cement or concrete. So all these supplementary cementitious materials, which are basically slag or fly ash, as contain to the extent of starting from 8 to 30% of alumina in this. So when water is added to this system, because of the increase in the pH, alumina dissolves and alumina gets converted into aluminum hydroxide gels. And these aluminum hydroxide gels will start coating this silicate grains that are present in the cement, thereby not allowing the silicate to further react. And this is one of the main reasons why you get a decreased early strength when you increase your SEM content. And even though these aluminum hydroxides are metastable, and over a period of time it will go away, but until that time it coats the silicate grains, it doesn't allow the silicate to further react. And what we have done here is actually we have added certain chemicals that will preferentially hold on to this alumina to get converted into aluminum hydroxide. The process what we call is as a chelation. Chelation is actually it preferentially holds on to the alumina by forming certain bonds along with that, and then it also supplies certain counter-reactive anions that will react with the alumina. So in a nutshell, the way in which Novomax works is the first step is chelation of alumina and iron and providing counter-reactive anions. When I say counter-reactive anions, it can be a range of anions starting from borates, phosphates, sulfates, nitrates. And these counter-reactive anions react with alumina and iron to form additional binding bases. So this is in a nutshell is the reaction mechanism in which Novomax and iCrete works. So this is a step. I mean, further when we compare to the conventionally available additives in terms of concrete and cement, these are all, even though we say it's a blend of micro minerals, we use only to an extent of 20 to 20% of micro minerals. So these are all. If you look at the blends of these are all pretty much in the same range of cement, and still be able to provide the properties that are given by a micro minerals. Next slide, please, madam. So this is the principle which is very common with both with iCrete and as well as this Novomax. The space between the CSH grains are filled with the reaction product of Novomax or an iCrete in terms of a concrete. Next slide, please, madam. So this is once again promoting the dissolution of alumina and iron present in the supplementary cementitious material, accelerating the hydration of the intermediate phases of the cement, and providing counter-reacting anions, increasing the rate of the silicate reaction, which I explained a little earlier, and then forming additional binding phases other than CSH. When we say additional binding phases other than CSH, we have seen in the Nexarty diagram, that calcium sulfoaluminate and hemicarboaluminates and carboaluminates are those additional binding phases that are formed when Novomax or iCrete is added to the system. And you might have observed in the scanning electron microscopy, there are many minute crystals that are formed when iCrete is added, which fills the gaps between the grain sizes of the CSH, which is the main reason for the reduction in the water permeability and an increase in the strength associated with the use of iCrete and also Novomax. Next slide, madam. So Novomax can be used for a different needs depending upon the individual needs of the cement plants. It can be used to decrease the clinker content, or it can be used to increase the fly ash and PPC and slag and PSC, or out of all the three, actually, I mean, people have been using this to increase the fly ash and the slag, and this is also been used as a waterproofing additive to promote a new type of a cement that is called a waterproof cement in the cement industry. Next slide, madam, please. So when you compare Novomax to the conventional grinding aids, it chemically reacts with the cement, whereas the conventional grinding aids doesn't react with the cement. So what the conventional grinding aid does is it increases the specific surface area of your cement and thereby increasing the initial rate of the reaction. Whereas with respect to Novomax, it chemically reacts with the cement to form additional binding phases, and it lowers the permeability of the cement, and it doesn't affect you on a surface area, and it aids in the increasing the SCM use. Next slide, ma'am. So these are all the typical results of Portland slag cement with and without Novomax used at 0.5%. And you can see that we have increased the percentage of slag from 46 to 50. Normally what happens is when you increase the slag by 4%, your one-day strength goes down by another 2 or 3 MPa. But with the use of this Novomax, even though we are slightly lesser in one day, it's very much comparable to the control. And if you look at the 28-day strength, we are fairly, I mean, around 4 to 5% higher than the control. Next slide, madam. So this is once again a trial results for Portland Pozzolana cement using Novomax at 0.6%. And the same case here, even though the one-day strength is marginally lower when compared to the control, your 28-day strengths are also like marginally higher. And a reduction of 7.86% of clinker is achieved through the use of Novomax at 0.6%. Next slide, madam. This is with respect to ordinary Portland cement. So the beauty of the Novomax is it not only helps to increase the SCM, but it also helps to make the Portland cement better in terms of achieving its early strength and also its later strength. So these once again reacts with the alumina and iron present in even in the ordinary Portland cement to convert that into a useful binding phases. Yes, madam. Next slide. So the roadmap, what we normally follow with any of the cement plant is actually once we receive the cement or clinker from the respective cement manufacturers, we do analyze for its physical and chemical analysis, and then find out how much of alumina is there, and then how much of what is this basicity, what is this acidity, and then we do with the trials with the different types of the additives, and then we formulate the additives that are suitable for that particular cement clinker. What I'm trying to say here is actually this is not a one solution that fits all. So this Novomax is different for a different cement manufacturer, and the same sample is sent for the plant trial and starting from the commercial supplies. Next slide, madam. Thank you. And once again, I thank for Mr. Kaushika and the QCrete team for giving this opportunity to present our ideas on this forum. Thanks.
Hello. Now is the question answer session. Question number 1. Measure the durability of concrete. Wait.
Can you repeat, madam?
Wait a second. A good sustainable product to optimize the cement content. A sustainable product, what is the effect of this product on density of concrete or SCC? What are the future scope of research on SCC with this novel additive? Asked by Bharti Ganesh.
Doctor sir,
Please.
Dr. You will answer, sir?
Again.
Yeah.
Hello.
Yes.
Yes,
Kaushika,
sir.
you want to go ahead?
Yeah, I'll just put my idea and then you can also put in it. As far as ICrete, when it is incorporated in concrete, it doesn't affect the density per se. Like for example, if the density of concrete is 2450 in control mix, this will be same actually, even though the permeability and is reduced and strength is enhanced and SCMs can be increased and things like that. As far as the sustainability of the concrete is concerned, since we are talking about either completely different approach of either reducing the OPC content or the reduction of total cementitious content itself, or increasing of either GGBS content or PFA content. In fact, some of the concretes we have done with 30% OPC and 70% GGBS, which have either equaled or given better strength with ICrete when compared to a 50-50 or 60 OPC, 40 GGBS mix. So the cementitious content can be reduced, or SCM content can be increased, or OPC content can be reduced. In all these ways, the concrete becomes more greener and the concrete becomes more impermeable, whether it is SCC or normal concrete, and hence the concrete becomes better in all respects actually. But the density is untouched. Doctor sir, you want to add, sir? Doctor?
Yes. As far as the future research in this area is concerned, we are already in the research of on the same lines of rolling out an additive that will have only 20% clinker in all your concrete mixes, starting from M20 to M60. So this is the next research that we are into. So using this a variant of an additive that is using the same technology platform, that we will be rolling out an additive with using only a 20% of OPC in the mix, and the rest 80%, and I would say like 75 to 80% using supplementary cementitious material. You will be able to get all your M20 to M60 grade concrete. Thank you.
Thank you, sir. Any durability studies have been done on ICrete concrete other than permeability test? Asked by Dr. B. Kameshwar Rao.
Yes, sir. As far as the durability is concerned, we have done a series of durability studies, starting from alkali silica reactivity and rapid flow rate permeability and initial shrinkage, and so on and so forth. These are all the list of durabilities that we have done.
Thank you, sir. Did you conduct the RCPT test to measure the durability of concrete prepared using iCrete? Asked by Dr. Ashik Bellari.
Yes. Yes, we have done the RCPT of concrete using the iCrete additive.
Thank you, sir. Okay.
And for
yes, yes,
just
you can continue.
For a high grade concrete, I mean the numbers of RCPT are somewhere in the range of 800 coulombs.
Okay, thank you, sir. Next question is, has this product been accredited by IRC as innovative material? Asked by Vivek Singh.
So the IRC is under process. Testing by IRC is under process.
Okay, thank you, sir. At what time we expect to start the event? Sorry, sir. Sorry. Okay. Next question, how to read or analysis XRD and SCM test results, sir?
I'm sorry, how to?
How to read or analysis XRD and SCM results.
If you can go to that slide, I'll explain. That the slide that which Kaushika was showing on his presentation. Yeah, previous one and the previous one. So if you look at it, this is actually a blank sample which doesn't contain iCrete. And if you look at the spaces in between the grains, you will not see any kind of a fibrous structure or any kind of a crystal growth in between. So these grains are like more of a cubes, or like kind of some kind of an amorphous structure you can see. But if you look at this, the next slide, madam, next slide.
Sorry.
So in between the grains, you see that these crystals which are grown, and if you go to the right side of the pictures, you can see that even a very small crystals are deposited on the grains of the structure. So this is how you differentiate between the one with iCrete and without iCrete. So with iCrete, there is a growth of the crystals that will fills the pores, thereby not allowing the water to enter and strengthen the structure. And if you go to the next slide, please. So there is a clear-cut intensity drop. If you look at somewhere around 20 or 25-degree angle actually, and look at the 28 days 25-degree angle actually. I mean, if you look at the intensity counts there, this is and if you look at the intensity height, this is substantially lower with iCrete and without iCrete. What it means is actually the extra CaOH2 that are produced are consumed in forming an additional binding phase. This is one that you can inference that you can come into. And at 7 days also, you can see that around the same 10 degrees angle, your intensity of the sulfo-aluminate peaks are higher with iCrete. Yes, madam. Thank you.
Okay, next. Thank you, sir. Next question is there any scope of doing research using iCrete? If so, how can I obtain this material?
Kaushik sir. You can probably get in touch with Mr. Kaushik. Am I audible?
Okay. Yes, sir. Yes, sir. Okay, yes. Sir. Next question is this product compatible with super plasticizers? Asked by Vivek Singh.
Yes, that is. Kaushik?
Mr. Vivek Singh, we have done trials. In fact, both plant trials in different places of India, all over India, and lab trials with more than 4,000 to 5,000 trials have been done, including commercial production, and it is compatible with all kinds of cements and admixtures. There is no problem at all. So all admixtures, the iCrete has performed well. As we discussed earlier, it does not affect the rheology or retention in any way. Yes, sir.
Thank you, sir. Next question is use in marine structures tried, asked by Radha Krishnan.
I'm sorry, use in?
Use in marine structures.
Okay. What it means is, can it be used in marine structures?
Use in marine structures tried.
Oh, Mr. Kaushik will be able to
Yes,
answer that.
yes. We have done a lot of trials in Mumbai region where very high grade concretes are done with very low water cement ratio, incorporating iCrete, where the RCPT values are very low and permeability is also very low, and hence this product incorporated in concrete iCrete helps to increase the durability, and it can be easily used in any marine structure. In fact, in some places we have used in acropods, which is directly in touch with water. So there is no problem. We can use this in marine applications. Thank you.
Thank you, sir. Next question will be, what will be the cost of iCrete and Novomax?
I think
Asked by Vinay, yes.
I think this is not the platform to discuss the commercial things. Actually, probably you can get in touch with us, sir. Please.
Thank you, sir. Next question is, what about the long-term durability of the concrete if we use these additives, sir? Asked by Bodhapati Ganesh.
So in terms of long-term durability, I mean, one can say that, I mean, there are certain accelerated tests actually which we have already performed, and then convincingly proved that it doesn't affect or it doesn't do any harm to the structures. And practically speaking, actually, this product has been used in the field and in many concrete places for more than 2 years now. Because if you're introducing a new product and there is an already existing product, or if you want to compare it with, so this we come across when we do with alternative cements. Actually, I mean, the moment when we say alternative cements, and immediately people ask for long-term durability. Long-term durability is Portland cement is known for 100 years, and we are coming up with an alternative cement which is a new kid around the block. So, to answer that question, we have done a series of tests that will give you enough, confidence in terms of its numbers that it doesn't affect the durability or it doesn't do any harm to the structure. Thank you.
Thank you, sir. Next question is, what is the chemical composition of Novomax? How it react with alumina and iron? Asked by Dr. Chandrasekhar A.
So the chemical composition, I said, unfortunately, we will not be able to disclose everything here. And the working principle I just told you is the chelation coupled by the supply of counter-reactive anions. When I say counter-reactive anions, these can be anything starting from nitrates, sulfates, borates, phosphates, and a mix of everything actually. And this is how it reacts in a nutshell.
Okay, thank you, sir. Next question is, what is the difference between additive and admixture in concrete? Asked by Syed Abid Hassan.
Kaushik ji.
Yes. See, we discussed earlier that an admixture, generally by classical definition of an admixture is added maximum to an extent of about 5% other than fibers, other than mineral admixtures, which modifies the properties of concrete in either fresh state or hardened state or both the states. But generally admixtures, when I say admixtures, they are generally refers to the set of compounds which act as surfactants, means it produces negative charges, and the negative charges uh, keep the cement particles away from each other, and hence increases the fluidity of concrete, or rather we can say we can reduce water content from the mixes, or we can increase the flow of the mixes. These chemical admixtures generally do not participate in chemical reaction to the extent that they don't change the microstructure of concrete. They generally act as surfactants, or they deposit the negative charges and keep the flow of concrete higher. That is how they change. Or some of the chemical admixtures we act like catalysts. They accelerate the process of hydration or decelerate the process of hydration. When we are talking about mineral admixtures, it interacts with the components of cement and hence produces a different microstructure. When we are talking about additives like iCrete and all, they also act with the alumina and iron present in the body of concrete, and hence produce different compounds which reduces the permeability. So additives, when we are talking about iCrete as an additive, it participates in the chemical reaction, that is hydration process, and produces different compounds, whereas chemical admixtures, which are popularly known as superplasticizers or water reducing admixtures or hyperplasticizers, whether they are based on PC or SNF chemistry, they act for a very short time, maybe 2 hours, 3 hours, producing charges and keeping the cement particles away from each other. That is the difference. Thank you.
Thank you, sir. Next question is, what is the pH of this additive? What is the stand-alone CO2 footprint of this additive? Asked by Yatin Joshi.
Yes. So the pH of this additive is at 10% dilution is around 11.5. And in order to answer the carbon footprint associated with this product, I can say that 75% of this product is made from the industrial byproducts, the waste from the another industry.
Okay, thank you, sir. Next question is, where is iCrete is used? Is this useful or not regularly where it is used? Asked by Nikhilesh Kamishetty.
iCrete as an additive can be used in all kinds of concretes, whether it is precast, pre-stressed, or remix concrete. In any way, wherever the concrete production happens, we can use iCrete. And in commercial concrete plants, many of the commercial plants in India are they are using. Actually, we are also exporting outside also. So many of the commercial plants, Readymix companies, and concrete manufacturers, and some small precast manufacturers are using iCrete as an additive. Thank you.
Thank you, sir. Next question is whether iCrete can be used along with SP to increase the flowability. Asked by Buddhapati Ganesh Kumar.
I understand SP is superplasticizer. Yes, superplasticizers are part and parcel now in modern concrete systems, whether it is ready-mix concrete or precast concrete. And the work of iCrete is to optimize the cement mixtures or enhance the strength or both. And hence, this has to be used, and this can be used along with superplasticizers. Yes.
Thank you, sir. Next question is, while the initial curing process of slab green color impression was observed, what were the reasons? Asked by Sharad.
We don't understand the question. Why the green color is?
I will repeat the question. While the initial curing process of slab green color impression was observed, what were the reasons?
That is because of the presence of sulfur in the slag.
Okay, thank you, sir. Why does not it affect the workability of concrete? Asked by Neha SN.
Why iCrete does not affect the workability of the concrete? So why iCrete does not affect the workability of the concrete is it does not chemically absorb onto the surface of the grains when you start initially, I would say. So that is the reason there is no, physical absorption of this iCrete components in the grains to start with. So that is the reason it doesn't affect the workability.
Okay, thank you, sir. That's it. Question and answer session is over, sir.
Thank you.
Thank you.
Okay. Thank you, madam, and thank you, Kaushika sir and Ramkumar sir, for clearing the doubts with a lot of patience and all very relevant doubts. Can I ask just one question?
Yeah, please.
Yes.
What is the pH of the pore solution once this material is added to the concrete? Is the pore solution pH altered?
Yes, there will be a slight increase in the pore solution pH alteration.
Increase?
Yes, there will be an increase.
Okay. So there's no reduction, because I was understanding that it is lime sequestering, no? So would the pH go down? That was my doubt.
No, there will be a slight increase in the pH.
Okay, so you might be bringing in more alkali ions into the solution with your products. Okay. And does the heat of hydration get altered with the? Because I was wondering, because you're accelerating the product.
Yeah, not to a very great extent actually. And that's the reason we always, when we use iCrete, we always recommend to use the increased SEMs. So it doesn't affect the heat of hydration to a very great extent.
Okay. One more doubt I had was, there was a discussion on mitigation of plastic shrinkage. However, when we look at the results, that it is the major manifestation of the product is in the 28 days at the later ages. So what is the mechanism by which the plastic shrinkage is being reduced? Is the flexural strength increase much faster?
Not really the flexural strength actually. When I showed the SEM pictures, I've showed the minute crystals that are being formed actually. So these crystals are nothing but that can bound an extra water. So because normally when plastic shrinkage happens because of the evaporation of the initial water, so these crystals holds an extra water that doesn't allow the water to escape.
Okay. All right, it's very interesting, and thank you for this interesting talk, both Dr. Ramkumar and Kaushika, Engineer Kaushika. And from ICI side, I would like to thank wholeheartedly the whole team of QCrete for organizing this webinar, and also all the participants who have joined this webinar today and actively participated in the discussion. And we will meet again next month with another interesting talk. I thank all who were involved in organizing this event. Thank you very much. Madam, maybe we can end the meeting.
Thank you.
Okay, ma'am. Okay, thank you.
Engineer Sanulal also for for introducing the guest. I forgot to mention. Thank you for doing that. Okay, now we will wind up the presentation.
Okay, ma'am. Thank you.
All right.
Okay.
Thank you.
Thank you. Thank you very much.
Thank you, ma'am. Thank you.